Hello, Precalc class. This is Miss Hanley here. I will not be with you guys today, but I am making a video so you can attempt to tackle assignment 4. You guys are going to be graphing logarithmic functions today. So before we get started here, I want to take a look at these graphs in Desmos. Alright, so the first graph I am going to look at is y equals 2 to the x. So this is the same exponential function we've been studying. Has a base of 2, a y-intercept of 1. So there's my point 0, 1. And it grows by a factor of 2. So the next point is 1, 2. Then the next point is going to be 2, 4. Ooh, I had it almost exactly. There we go. And then the next point would be 3, 8, etc. And then you go backwards and you get negative 1, the half, approximately. Okay? We're going to look at something called a logarithmic function today. And that looks like y equals log. And this little subscript of 2 here is the base, so log base 2 of x. All right? So a couple neat features of this graph versus the exponential one. Well, exponentials have that horizontal asymptote, whereas logarithmic functions have a vertical asymptote. Okay, so we're going to be looking for that this time. And if you think about the y-intercept of the red function, it was 0, 1. The x-intercept of the blue function is 1, 0. That point is mirrored. All right. We had another point in the red function which was 2, 1. Or sorry, 1, 2. And on the blue function we have the point 2, 1. All right. And so if we create another equation here, which is the line y equals x, if you take a look at the blue function versus the red function, these two are exactly the same distance away from that green line the entire way. So the entire time they're graphed are the same distance away from the green line, right? And so this is because when they're reflected over the line y equals x, you have two functions that are inverses of each other. So just like x squared and square root of x would cancel each other out, 2 to the x and the log base 2 of x, those would cancel each other out as well. And so you're just left with x. So we're going to be looking at logarithmic functions today, which are the inverse of the exponentials you've been working with. Alright, so let's talk about the transformation form here. So the first thing is we want to identify all these pieces, and there's nothing different than any of the other transformations that we've done. So let's talk about A. A, if you recall, is always our vertical stretch. Alright, so we're going to be looking for a vertical stretch. It doesn't act like the y-intercept like the point, the A value did in the exponential function, but it is going to be important for us. B is our base. Alright, and so we're going to use this to find a critical point in our graph, which is b, comma 1. All right. This point is going to be on our graph before we do any transformations, so that's an important part. Before transformations. X minus h, this is going to give us our vertical asymptote, similar to like what you guys just did with rational functions. And then plus k is going to be our vertical shift, so moving this graph up and down. All right, so let's try one together, see if we can identify all the pieces. So the first thing that I'm going to do is find two critical points. One of those points is the point 1, 0. It's that x-intercept we just saw. This will always be a point on your logarithmic function unless you have a number in front of x. So if your equation looked like log of 2x rather than just log of x or x plus 1 or something, this is the only time that you would get a different x-intercept. But for everything I'm going to give you, you won't need to worry about that. So 1, 0 is going to be always a starting point, and we'll use our transformations to move that around in a second. The other is b, comma 1, and in this case our base is 3, so the point 3, 1 should be on our graph somewhere. So let's plot those so we can think about them in a minute, 1, 0, and 3, 1. Other notable pieces are that I have a vertical stretch. Oops. I can't spell today. Vertical stretch of 2, and that's coming from here. And then I have a vertical asymptote at x equals -1, which is coming from here. I'm taking the 0 of that. And I also have a vertical shift of -4, which is coming from here, right? And so let's go ahead and draw in our vertical asymptote here. There's that. And then let's start with the point 1, 0 and perform our transformations. Well, we have a vertical stretch of 2, and so whenever you have a vertical stretch, you need to multiply your y values by that number. So I'm going to multiply my first y value, which is 0, by 2, and 0 times 2 is still 0, so I get the point 1, 0. All right. When I do that for 3, I'm going to get the point, so I have 3 and then 1 times 2. Oops, that doesn't look like a 1. 1 times 2, which is going to give me the point 3, 2. So if you notice, the point 1, 0 did not change, right? But 3, 1 got stretched by 2, and that's because the y value in the first one was 0, and it wasn't in the second point. So this 0 can't really get stretched, but a value of 1 can. The other thing that we want to do here is the vertical shift of -4, and that's going to be applied to the y value. So we're going to take 4 away from our y values. So now I'm going to get the point 1, -4. So I'm dropping this down, 1, 2, 3, 4. So that's a point on my graph. And over here I'm going to get the point 3, -2. So I'm taking this point here and dropping it down, 1, 2, 3, 4, and I get the point 3, -2. When you have 2 points, then you can go ahead and graph your function. You want it to pass through those 2 points and hug your vertical asymptote, which would extend. If we extended our graph a little bit, it would extend all the way down. And then this graph is going to continue increasing in the positive direction and hug -1 as an x value on the left. All right, and that's all there is to it. So you have to find 2 points in a vertical asymptote. So try the 6 graphs you have in assignment 4. When you finish, go to assignment 1 and work on the Khan Academy link in assignment 1, getting 75% correct, and submit a screenshot. And then if you have time, also go on to back onto assignment 4 on Schoology and try the Khan Academy link there, getting 75%. If you don't have time to do that in class, you can save that till Wednesday. Friday of this week, we'll have a quiz over graphing exponentials and logarithmic functions. So please make sure you're trying and you're asking questions. That will be your last grade on quarter 3. All right, I hope you guys have a great day. See you soon. Bye.